So now I just want to welcome you to my session, Add More Protection with HTTP Security Headers. My name is Cecilia WIREN, and I like to call myself a coding security advocate. I love to talk to my fellow developers about coding more securely. And to state that security isn't important, that's like saying that kittens aren't cute. It's basically not true. So before we start, I just want to get a shout out to my company Active Solution. We're based in Stockholm, and they are really nice to let me do those kind of community events like this. So what's really an HTTP security header? Out on the internet, we have a lot of servers with a lot of different things to load, web pages and stuff like that. And on the other hand, we have a lot of clients with their browsers. And all the web browsers can browse the entire internet and download whatever content they like. And when we do that, when we are visiting a page, we're ordering our browser to load a page. And that request will be sent to the specific web server where the page is located. The server will serve you the page together with some metadata. And that metadata is called, some of the metadata is called headers. And headers are a way to tell the browser how to behave, how to interpret the content. So for example, you can tell the browser how long is the content and what kind of type is it, so the browser knows how to render it or execute it. And amongst those headers, there are headers that are related to security, and that's why they are called HTTP security headers. So we have a lot of different headers in our responses. And those are just examples of some of them we are going to talk about today that are HTTP security headers. So what we basically do is telling the browser to behave, to restrict its just to limit it to not load everything from everywhere. So if you, and the question is, how much is this used? And for that, I want to quote Scott Helm. He's doing a study twice a year on the top million sites that are used, and then looked at how much are the security headers used. And he found in this last study, that was in September, that basically around 14 to 16% of the security header was used on, 14 to 16% of that 1 million site was using security headers. And if you look at except one specific header that's called content security policy, that's only used for like roughly 5%. So this is why I think we need to have this talk to add more security headers to make it more secure for the user to browse the web. So let's dive into the first one. We have 6 of them to talk about, and let's talk about the first one. Sorry, I want to say that you can read some of the things I talk about at my blog, and if you are missing some kind of information afterwards, you have my contact information at my blog as well, and there's my Twitter handle if you want to contact me directly. So let's go to the first one. And that one have a kind of history. In the early stage of internet, some people, developers, were not explicit about the content. They didn't state what kind of content type the content was. So they didn't state it was an image or a JavaScript, or if it was a HTML file. So basically, every browser implemented something called MIME sniffing, And that's basically when you look at the file and look at the first byte to determine what kind of file this is. So it basically ignores the content type header and gonna look at the file. And this was becoming a problem because if someone injected some kind of file where you're supposed to have like a style file or a script file and make it, and you added an executable instead, the mainstream would execute the file instead of trying to interpret it as a style. Luckily enough, most of the browsers today doesn't do this, but it's still a good practice to add a secured header. And the header we want to do is called X content type option. And you see an X prefix here, and that's because when the header are developed, they add an X prefix to tell you that this is under development. You can use it, but it's not sure it's going to be like this and before it's standardized. But in this case, it is standardized. So the problem was that when they first had the X prefix, and then when it was standardized, they released without the X prefix. People got confused, and there were browsers that supported X and not the standard, and you had to like, if you had adopted this header, then when it got standardized, you didn't have it anymore. So they basically kept the X for the standard, but nowadays they actually don't use the X at all, so you can't tell by the name if it's a working standard or not. So, but this one is called X content type option, and you have one option of value to add, and that's no sniff. So it's just one value to add. And to add this, you do differently if you are in ASP.NET Core or regular ASP. So for ASP.NET, you use the Web.config file. And you add your headers inside the custom headers, and you state the name and the value. So since this only have one value, it's really simple thing to add. And if you are on core, you want to add it in your middleware. So you need to look for your Startup.cs file and for your configure function. And inside of that, you add it to your application builder with this lambda. And you add your header to the response. So, are there any questions this far? Are you keeping up? No? You will be able to ask me after, at the ending as well. Now look at number 2, and then I want to talk about HTTPS. Everybody's talking about HTTPS. But why is it really important about HTTPS? Let's have a look at our friends, the server and the browser again. When we are asking a server with a request and when we get a response, if we don't have encrypted traffic, the traffic will look something like this. You have in plain text all the data that's sending from the browser to the server, and everything the server is serving the browser is stated in clear text. So if there are any compromised parties between the browser and the server, they could read the content or alter content. So it's a security issue and also privacy issue to always use HTTPS. And if we do, the talking between those two parties would look more like this, unreadable. So we want to state to the browser to always use HTTPS. And we do that by header. And that header is called strict transport security. And what we will do is when the browser have the first call to the server, we're going to do a response. And in that response, we're going to say, next time and every time after that, always ask me over HTTPS. So we do that with the strict transport security header. We have a couple of values to add, and that's to state that we want to include subdomains. You should do that so you are secure on every path. You should also think about and add your max age. How long should this policy persist? And to think about here is if you add this for the first time on your site, you shouldn't add like a year or a month or something like that, because if you have some kind of problem and there are users that have gotten the policy, those browsers will persist with only HTTPS for example a year if you stated a year, and there's no fallback to HTTP. So with the policy, you're strict about always use HTTPS. So when you are adding this for a new site, you should start with a really low value to make sure it works. So maybe you start with 5 minutes and see if it works. And then you can add like a day or a week, and you continue monitoring and see that everything works. And at the ending, when you have ramped up, you can end with like a year. But there is a problem here. That's the first call from the browser to the server. That can still be HTTP, because the browser doesn't know about this rule unless it has gotten the first response. And if that's the problem, we can actually add a preload. And that's the last value we can add. And that we're going to tell it that for the very first time to visit our site, always use HTTPS. So to be able to do that, you have to make sure it works. You add the preload value, and you go to this site and register your site. So this site is a complete list of every site that needs to be loaded with HTTPS and are used by the browsers. So that's how the browser knows that your important site need to be preloaded and always be accessed from HTTPS. So let's add this in code. In Web.config, we add it as the same as before, and when we have several values, we separate them with semicolon. And for ASP.NET Core, we actually have a function. So instead of writing strings, we can call just app.usehsts. But we have to be careful now, because if you only add this, you're going to get default values that aren't really good to have at your first add, because the default value of max age are 30 days. So you really should configure it as well, and you do that in your configure service function. So you make it include subdomain, and you add a max age and start it with a low number, as I stated before. So, any question about this? Crystal clear. Next one. Content security policy. This was the header that had the lowest adoption rate. This was only used at 5% of all 1,000,000 sites. So what does content security policy do? With that header, you're going to tell the browser what kind of content it can load and from what sources it can load. So if you take a site like this, we have some styles, and we have a widget from Facebook, and probably some scripts and stuff like that. And if you add the most restricted content security policy value, that's default source none. And now we're telling it to not load any source at all. No images, no script files, no styles, no nothing. And the site would look like this. It will be very broken. So we probably don't want to use that one, but the default source is a good value to add for those resources that you haven't stated. So a much more better default source value should be self, because then you're telling it that it's okay to load things that are from the same origin at the site. And we add more kind of directives to tell it that images are allowed to be loaded for my CDN, for example. So now I was stated that the image can come from the CDN, but it nowhere else. So if I have an image on my site myself, it's not going to load it. And if I want to combine it, the sources I can. So maybe for script, I can say I have some for myself, and I also need to load script files from Facebook since I had this Facebook widget. And I can also make it tell me when things go wrong, because the arrow is going to be on the client computer on the browser, and I have no way to knowing what was going wrong after we have sent it out the page. There's nothing with when we are rendering or compiling or something like that. So we actually have a way to report back. So we have a value of report to, and we can set up an endpoint that are collecting things that go wrong. So every time the policy is enforced, so for example, if you try to load an image that are not from my CDN, it's gonna not load the picture, and it's also gonna send a report back to me so I can see it. And in the earliest version of content security policy, this report to directive was called report URI. So you should include that as well for those browsers that haven't implemented the latest version of content security policy. So now when I have gone through and added all my resources and where they could come from, my site could look like this again. But now I'm secure. If I get some kind of injection of code or something that try to load scripts or something, that will not be allowed. So I have set the stage for the browser to know where my safe resources are. But we have some kind of resources that we don't really have in external files or external places, and that's our inline code. So if you have styles or scripts that are inline, they will not be enforced. They will not be used unless we state so. So my first recommendation is actually to not have inline. So move out the styles and use a class to reference them, move out the script to a different file. But if you really have to have inline, you can state that script source are allowing unsafe inline. But that's not really recommended because, as it's stated, it's unsafe. So if you are allowing inline script, you are allowing someone to inject script there if they find a possibility to do that. So instead, I would recommend you to either use a nonce, and a nonce is basically a couple of random bytes that you state in your script source, and the same nonce you have to use in your script. So you tag the script with the same nonce as in your rules, and the browser will know that this script is okay. But what you have to do is this need to be not static. It has to be generated when you call the site. So it will be different every time. Otherwise, it will be still vulnerable. And the second option you have is to actually use a hash. So if you take the whole script or the whole styles, you can run it through a hashing algorithm, and you get a hash. And then you can state that hash inside of script source. And it basically can do a hash sum on the script to make sure that it's allowed to run or not. The problem here is if you alter the script, you have to update the hash. But you don't have to add anything else inside of your script or style. Yeah. So back to how we're adding them. Web.config, we add in custom headers, content security policy, and we add all these kind of values. Yeah, I see them correctly. So I've done a line break here just to be able to see them better. But it's basically the same that I showed on the last page. It's the default source to self, image to my CDN, the script source to self and Facebook, and my report URL to be able to receive report of violations. And inside of Startup.cs, in the core case, you do the exactly same thing. You have to have the strings and tell it to add the headers, content security policy, and the same values as well. So it can be really hard to do this header, and that's probably why it's only 5% adaptive. So what should you do when you're trying to develop this thing? I would say test in production. Just ship it out there and see what's happened. The problem is that you're probably going to break your page, and you don't want to do that. So instead of using the real header, you can use another header. It's basically the same one, but it's named report only at the ending. So it's another header, but you can apply the same values, and it will not enforce the policies, but it will report the violations against the policy. So when trying out new policies, you can add this and add your new rules. When you see that you don't get any report that are that you don't expect, then you can change it to the content security policy and move on. And since it's a bit complicated to do this, I'll only show a couple of the sources you can state. I recommend some tools to use. And the first tool you can use is the report URI. So this is a good place to register and have your endpoint for your report. So you don't have to set it up yourself. And they have a free tier you can start with. That's really nice. And on the same site, we have a couple of tools. So there's a tool for validating your CFP. So you know that you have stated it correctly and use the right spelling. You have actually a tool to build one where you can checkbox the things that you want to have, and that would generate the code for you. And they also have this hashing tool. So if you wanted to do a hash on your script, you can just paste the script in, and you're going to get the hash value. And the last tool I want to tip about is the CSP validator on Google that also can validate if it's a valid, if your values are valid. Yeah. Any question about CSP? Yeah. 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 So the question is, let's see it here. The question is, we have the report to, and it's for an API, but he expects this to be more like an email. So you don't really want emails here, because then you got to get spammed, something like that. So, and how it works is that the browser has implemented a support for report to. So it is the browser itself that's going to send out a call to the API with the violation data. So it's going to be structured in a way that are standardized. Yeah. What's it? It's going to, okay, so the API is going to receive it, and depending on if you write it yourself or if you use this service, you're going to get JSON with what policy was broken and from what source was it trying to load it. So you're basically going to get data and if you look at, and you're probably going to put it in some database and you're going to like read it up and do a report, a summary, and see if it was just one occurrence or it's several occurrences and stuff like that. So that's how you are looking at it. It's a blob, and you can store it and organize it yourself. And in this, let's go here again, sorry. In this tool here, they actually are going to analyze the data, not just going to store it. So you can actually, if you are using this tool to collect your report, you can get it to generate rules that are going to allow what you got for report. So you're going to see what, so this is basically when you're adding new stuff to your page, you're probably going to get new reports. You're going to probably see reports for something else. Maybe the user are using some kind of extension, or even if you are infected or stuff like that, then you're going to get a report of things that are trying to be loaded. So, did you grasp? Oh, yeah, thank you. This was one more question, I think. Let's see if I can hear. I'm going to talk about, what is it? Yeah, now I got a real question. Yeah, state it again.
Okay, so I was asking, how is this policy different from the same origin policy?
The same, you are thinking about,
because it also forces you to get content from the same origin. By default, all browsers enforce it. So maybe
yeah, I don't really know what headers you are thinking about. Same origin is usually some kind of value you can add to a header. We're going to see that example later on with a value that are same origin, but there's no header called that. So let's revisit your question at the ending and see if things are clearer.
Okay,
so,
thanks.
Yeah. So can we move on, or is there one more thing? Yeah.
You mentioned this adding hash, basically,
yeah.
You know, to have like the more secure way of loading the JavaScript and to make sure that it's not tampered with. But what I don't understand is in what way you can actually, apparently, whenever you change the script, you have to regenerate this hash to rehash basically. But and that nonce dash as well, that thing is as well. This is like related. Because this is dynamic, and you mentioned that it has to be generated every time that user requests a page.
Yeah.
In what way you can make this happen in ASP and classical ASP.NET or Core? Because in Core, I could probably imagine, because you kind of configure it through the code statements. But how you go about it in the Web.config?
Yeah. So first, for the question is, how can we manage this when we have dynamic generated content? So basically, for the hash, you don't regenerate it. It should be a static value that you are printing in when you are compiling. So that you shouldn't generate that in runtime. So that's one thing. So that one shouldn't be affected of the thing that you are dynamically creating things. About the nums, as you said, in Core, there are some kind of support for this. There are libraries that you can bring in that helps you with tag helpers and also inside of the middleware. But for basic ASP.NET, you want to add it in your Web.config, as I told you, but you can actually add code directly to headers or in your regular ASP.NET Core file as well, if you are intercepting when the response is created. But it's not as easy as adding it in config file. Yeah, yeah, yeah. So you have to do it like in global AX file, where it is the last stop before you're sending things out.
Okay, so basically there is no easy way to do that in a
No,
classic.
there are some. You can probably find some libraries for that too, but it's easier in ASP.NET Core, yes. Yeah. That's not easy enough. It's not native easy yet. I really hope they're gonna add something for it, but there are a lot of different frameworks out there that you can find that helps you with this.
Okay.
Yeah. Okay. So we move on. We are at next one there. X-frame options. Once again, an X, that is a standard. So this is basically kind of replaced with CSP. So you can state the same thing as theirs, but since these are something that the browser need to implement, there are a lot of browsers that haven't implemented all of the CSP yet, so you should add this as well to be compatible with all the browsers. So what we really want to tell the browser is don't frame my site. Don't add my site inside of a frame, either on my own page or at someone else's page. And we can do we have some options. We can say that it's not allowed anywhere. Don't frame my page. Or it's okay to frame me at the same origin. So the same site can frame myself. Or you can specify a specific site that are allowed to frame me. The limited here is that you can only state one of those. So you can't say that it's your own site and another site. That have to be done with the CSP. So to implement this, once again, we add a custom header named X-frame options and our value that we want to have. And I would recommend you to also add it inside of the content security policy, and there it's named frame ancestor. So if both are present, the browser is going to use this CSP if they have implemented it. Otherwise, it will be a fallback to the X-frame options. So in the ASP.NET case, we do it once again in the startup. We add a header, and also here add it in the content security policy with frame ancestor. And if you have your self is the same as same origin here. Yeah. So any question about the X-frame options? Yeah.
I have one question. Why it is so dangerous to allow include my page into frame on another page?
Yeah, good question. I missed that. Pondering that someone register a similar URL that you have, and then they framing your page. So when the visitor go to your page, they will not notice that they aren't on the wrong page, but they also add an invisible layer on it there and add their own components to capture the click events and stuff like that. Then you could basically, on that site can basically steal your session cookie or fooling the user that they are doing something else than they're doing and stuff like that. So that's basically why you want to add this. Good question. So, for the next one, pointing. When we are browsing the web, we are leaving a trail behind. When we go from one page to another, we always going to refer to where did we come from. And when you go to the next page, we're going to say, where did we come from? And that's the URL. And the URL can contain some privacy information or security information or just internal information that you don't want to display. and don't want to give up over to the other page. So it can be like my page order/123. Then you don't want them to have that kind of thing. It can be maybe like code for when you are resetting passwords or something dangerous, or just personal information. So what you want to do is to try to figure out what kind of information do I want to send to myself and to others when I move around at my pages. So we're going to tell the browser, don't tell everything. And we do that with refer policy. And you will find something called referrer inside of CSP as well, but that's actually deprecated. So, so in this case, we should use this header. So for this header, we have some values, again. And it's a long list. I need to have my sheet. So first of all, we can say unsafe URL. And with that, we say that it's OK. We are going to expose your full URL to everybody. We can also say same origin. And with same origin, we say it's OK to allow the full URI, but when we are moving from HTTPS to HTTP, don't include it. So when you go from encrypted communication to not encrypted communication, we're not gonna send it. So it will not be detected on the network. And the next one is no refer. Basically, don't send anything. So don't send the URL at all. I hate this. I'm a site owner myself, and I like to look at my Google Analytics and see where all the traffic comes from. So for my blog, I can see if my traffic comes from a newsletter or a conference site, or basically from Google search. So I don't really like this as for statistics, and it feels like cruel to do to everybody to just don't say anything. We have no refer when downgrade, and they basically is sending everything, but if you are moving from HTTPS to HTTP, don't send it. We have origin, and that is only send it when you send it internally in your same origin, in the same domain. And also, only say the base URL. So if you have mysite.com/order/123, it's only going to send mysite.com. Strict origin, same thing, but we don't do downgrading when we are moving from a secure line to an unsecure line. We have origin when cross-origin. You send the full URL to yourself, but for others, you only use the base URL. And we have strict origin when cross-origin, and that's when you send the full URL to yourself, on the base URL to others, and you don't do downgrading. That's a complete list. And the recommended values to use are either non-referred when downgrade, strict origin, or strict origin when cross-origin. The last one is my favorite, because I myself would have like the whole story, and others will get the information and statistics about where we redirected them today, and we are avoiding downgrading. Yes. So to your code, we add it in the Web.config, same as before, refer policy. We select one of all this. We can't combine them. And in ASP.NET Core, we add it in the same way, but in the content response header add function. So, any questions about refer policy? No. now it's the sixth one, the really last one we're going to talk about. And that is called feature policy. And this is actually still under design. It's out there, you can use it, but it's not officially standardized for the whole thing. But some of the values inside it are standardized. So it's ongoing, and it don't have an X, as I told you before. They have stopped doing that. So you should start adopting this now. And some browsers actually don't have implemented it at all. Some browsers have gone very far and implemented it a long way. But what it does, it's similar to CSP, that it's limited different things from different source, but in this case, it's features. So it's more like the camera or the microphone or the vibrating thingy or the geolocation and feature that the browser can use. So this is a way to limit your application's attack area. So if you're stating that you are using the camera, then there will be no third-party code on your page, either that you added yourself or illegally, that will try to access the camera. Usually the web browser will ask about this the first time, but if you have a feature policy that you don't allow it, it will not even ask about it. So it will just block it. And there's a really long list here. We have 21 features that are standardized today, and we have 3 that are proposed that basically are tried out and they have found how they want to do it. They just have to decide that it's going to be standard, and they have 12 in experimental mode as well. So I'm just going to show you some of them directly in code. So we do it in ASP.NET Core this time. So feature policy, we could add a statement that the autoplay shouldn't be used. So autoplay for audio and video will not be. So they will still work, but they will not autoplay. And we can state that no one is allowed to use the camera because we don't have that kind of code on our page, so why should we? We can also state full screen and state a star. And a star say that that's allowed. That's allowed for everyone. We can also state that there's a specific site that can access it. So maybe for geolocation, if you have some kind of Google map and you want that one to work, they have to access the geolocation function in the browser, and then in this case, you can state that one is the only one that are allowed to use it. And you can also combine, so you can say, like the microphone, if you are using that, you can say that yourself is using it, and also this URL or this API. So you state a lot of different features and telling it if it's allowed and not allowed and who's allowed to use them, basically. And just for reference, Web.config, the same thing we have seen before, the feature policy added as a custom header. Sorry. Yes. So we also have a report-only header here as well, similar as the CSP. So if we want to try it out and make sure that we don't break the page, we can use this header as a first, and then when we are certain that it works, we can switch to the regular header. So, any question about feature policies? Great. So now we have talked all about the different headers. I just want to go back to the ASP.NET Core, because I said that you can add it in your middle tier, and I show you how you can do it natively in ASP.NET Core. But you could also add some kind of middleware library to make it more easy. And you could basically search for middleware headers or middleware secured headers. And I would recommend you to start looking at this. They have a lot of documentation. They actually have libraries for non-ASP.NET Core as well. If you go to the documentation, you will find what the names of they are. And you can basically add code that looks like something like this, the same way that app.ahts was looking like. So you don't have to care about strings and misspelling things. And that's a really good way to work, I guess. Yeah. So, quick summary of all the headers, and so you can take one picture away. We talked about X content type options. We are telling the browser to not guess the content type, not to do MIME sniffing. We talked about strict transport security. Always use HTTPS. We talked about content security policy. Tell the browser what content they can load and from what resources, or from what sources. We talk about X-frame option to tell the browser not to put my site in a frame. And last, we talk about refer policy to make sure that we are telling the right amount of information in the refer to a different site. And last, we had the feature policy, telling it what feature you are going to use. And last of all, and most important, we learned that kittens are cute. Now we can take a picture if you like. And if there are any more questions, you can come up afterward, because I don't want to stand between you and the lunch. So I just want to conclude that go home, add security headers, and do the world a better place. Thank you.